Let us look at the simple demo of cryptography. You'll get this file from the resource section. Let me open it. Then this is a simple file we have here. So first of all, we are using this crypto library of Python to get the prime, inverse, and so on. So you need to install this library. I'll show in a moment how to install it. And some of these import statement have been used here. A simple import statement, nothing fancy. Let us see the code. So first of all, what we are doing is we are taking the plain text. So this is basically created randomly. So this is our plain text or the actual message, but this is created randomly. Instead of this, you can also have something that is the plain message, maybe some sensitive information. Let us say plain can be something like password instead of generating it randomly. But here, let us generate it randomly. So we generated this randomly and we print that, just printing the plain message that has been generated. Now the RSA algorithm starts from here. So first of all, we get the two primes as stated earlier in the previous video. First of all, we get the two prime. Here we use 128 bits. You can also use 512 bits to make it more larger. As the number becomes larger, it is very hard to crack this RSA algorithm. So the strength of the RSA algorithm is determined by the value of P and Q. Here we use 128 bits, but instead of just generating them, which would take time maybe a little bit, we're just using this sample P and Q value. This will be P and this will be Q. You can also generate and test on your own. So we have now P and Q. I'm just writing here for the demonstration purpose because I need to show you like what the P's and what the Q value looks like. But in practice, you can generate them, that is randomly each time. But here we are fixed. We are using the fixed P and Q values. Now using the fixed Q and values, P and Q values has been fixed. Now next is to find the value of N. If you remember, this N was nothing but the combination of N and E gives us the public key. Now here we got public key. I'll just comment this out. Public key is nothing but the combination of N and E. Now this E, remember, this E is also randomly taken. It is an exponent which should be basically within the range of E and phi. Remember, 1 and phi. So phi is a Euler totient coefficient which is also calculated from P minus 1 multiplied by Q minus 1. This is totient, so we call it as totient coefficient. So phi is also calculated. Now calculating phi and calculating this N, we have this D now. So D is nothing but the private key. This is private key. Now we know N and E and D. So that means we have public key and private key. Now using that public key and private key, we can generate the ciphertext. So using E and N, we generate the ciphertext. So this is the demo. So how you can use RSA algorithm. Now let us generate the ciphertext. I'll just open the terminal here. And here what I need to do is I need to make sure that first of all we install this PyCryptoDome. So pip install PyCryptoDome. In my case, it should have been already installed. If it is not, it will install now. Okay, already satisfied. So you need to install PyCryptoDome first, and then we will see Python demo.py. So is the file name demo? Yes, demo RSA. The file name is demo RSA. So you can also do ls and Python demo RSA demo rsa.py, and you can see this was our original message and this is what we got after encrypting it, which is also easy to crack because this is also a very small number. you can always use big numbers to make sure that RSA is not that is cracked easily, because here we can see our P and Q values are very small. So if the value of P and Q are very small, that means n is what it is visible, because n is a public key and n is made out of P and Q. Now if we can clearly factor, so factor means finding the value of P and Q. Now if we can easily factor n into P and Q, then that means it is easily cracked. So that means we need to make sure the value of n is very very large, so that it is near to impossible for the machines to factor the value of n. So that is the important thing about RSA algorithm.